Hi everyone, Mrs. Below here. In this video, I'm just going to continue highlighting the important concepts that will be on the Chapter 2 test. So next, I'm moving on to density. So density as a concept, in terms of its definition, is how much mass do you have in a given amount of space. So how many atoms, molecules, elements, whatever, particles do you have in a given amount of space or volume? Because remember, density equals mass divided by volume. So we can look at density like this. We can also look at it in terms of comparing things to each other. So we can compare the same substance. So for example, solid, liquid, gas. So if you're talking about the same substance in terms of it being in different phases, solid, liquid, or gas, the solid phase would be the most dense, right? Because the molecules are, or atoms, elements, whatever, they're closest together. Liquid, they're a little bit farther apart, and gas, they're very far apart. Again, this is for most substances. There are a couple exceptions, such as water. That's an exception to this rule because liquid water is more dense than liquid ice. Okay, so again, this is also illustrating here, will something sink or float? So ice will float on liquid water because water in its liquid form is more dense. The molecules are closer together than ice, which is water in its solid form. Again, that's the exception to this rule here. We can also look at density in terms of if we have two objects. So let's say these two, they both have the same volume. So they're taking up the same amount of space. However, maybe this substance, the molecules are like this arranged. Maybe in this substance, this is how the molecules or atoms are arranged. So this one right here would be more dense because those atoms or molecules are closer together in comparison to the substance where they're not as close together. Again, kind of the similar idea with the solid, liquid, gas, except for now we're just comparing two different substances. So these two substances have the same volume, but they each have different mass. This one would weigh more. This would be heavier, and that is because it is more dense. So even though these two objects look like they're the same volume, they're taking up the same amount of space, one is heavier than the other because this object is more dense. We can also have two objects that have different volumes, but they have the same mass. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have these two objects here. They both have the same mass. So they have the same amount of particles, right, or atoms. I counted 8 of those dots. So they have the same mass, they have the same amount of particles, but they have different volumes, right? This one has a larger volume in comparison to this one. And that's because this object is more dense. So in order for it to weigh the same as something that is less dense, we need to blow up this object. It needs to take up more space because it has less atoms per its unit of volume. So we have to have a larger volume in order to have the same amount of atoms as something like this that is more dense. It's kind of like the what weighs more, a ton of bricks or a ton of styrofoam or feathers. They both weigh the same. It's just that you would have a lot more like styrofoam in comparison to the one brick because the styrofoam is less dense. And then lastly is density calculations. So remember, you can use the triangle here. So if you are solving for density, so you're solving for this variable here, you look at the relationship between the other two variables. So you can see that mass is over volume. Versus if you're solving for, let's say, mass, or like, let's say you're solving for volume, okay, look at the relationship between the other two variables. The mass is over the density. Versus if you are solving for mass, look at the relationship between the other two variables. Density and volume are next to each other, so it would be density times volume. Now, another key thing to remember is your units. Okay, when you're plugging numbers into these equations, I would highly suggest writing the units with your numbers, because then that's going to help you to determine if you need to convert any of your units so that they cancel out. So let's say that usually goes for when you're using these two right here, okay? So let's say that you are solving for the volume, okay? Right, it's mass divided by density. Well, what if the density is, I don't know, 2.5 grams per milliliter, and then the mass, let's say, is like, I don't know, 500 milligrams. Well, these two units can't cancel because they're not the same. So what you could do is you could convert that 500 milligrams, you could convert it into grams by going 1, 2, 3 to the left. So this would be 0.5 grams. Now those units are the same, so they could cancel out, and your volume would be in milliliters. So as far as those metric conversions go, sorry, I had to find this. I would really recommend putting this on your periodic table, okay? Again, the main ones we're going to be using are our base units here. So usually like grams and liters, and then centi, milli, and kilo are the main ones that you're going to be using. So like I did up here, I was going from milligrams to grams. So I was starting here at milli, and then I went 1, 2, 3 decimals to the left to get it into grams. So again, just make sure you're writing your units in the equations when you're plugging in, so you know what your answer will be in. You know, for density, if you have grams in the top, milliliters in the bottom, well then your final units would be grams per milliliter. And again, it's important when using these two equations to put the units in so you can make sure that they're canceling properly, so you can get your answer, you know, in usually grams or whatever for mass, and then for volume like milliliters or liters, depending on what the problem gives you and what I'm asking for.